everybody, and thank you for coming to this session. Who would think that Linux-PAM would be so interesting these days? Well, certainly not me. Before starting the talk, I would like to ask you, how many times this week have you been entering a password or using a fingerprint scan or maybe a dongle to access your system? We're doing this routinely nowadays, so it's not likely that you are actually counting this. But how many times did you think what's going behind the scenes? I don't think, unless you're debugging something, I don't think you did. So today, we're going to talk about the main part of the thing that implements this magic behind the scenes. My name is Dmitry Levin. I've been contributing to Linux-PAM for more than 2 decades now, and I've been a release manager for a few years. And today I'll guide you through this Linux-PAM demystified thing. So today we will talk about what Linux-PAM is and why it appeared, about core concepts of it, and we'll be talking a lot about configuring Linux-PAM. Also about the most mysterious thing, which is called frozen stack. Well, and if we have time, we'll touch on troubleshooting things. So what actually Linux-PAM is? It's a framework of shared libraries and a lot of plugins, which are also shared objects. They are pluggable, and the way where pluggable is described by configuration. Like, every service has its own configuration, and these configurations could be quite sophisticated. So the purpose of this is to let the sysadmin to choose how applications authenticate users, and to allow them to switch between various authentication mechanisms without need to modify and recompile applications. So it was not this way in the early days. In the beginning, like, it was very simple. Like, even etc shadow was not in the very beginning, and the way services authenticated users was really simple. Like, you grab the password, hash it with a salt from a, well, it was not a shadow entry yet, from a password entry, and then decide whether it matches or not. So, like, every application was doing this by itself, but because it was very simple and straightforward, it was not an issue. So later, etc shadow was introduced, and well, the process became a bit more complicated. But, well, as you can imagine, to introduce a new authentication method, especially a more sophisticated, like Kerberos or whatever, like, you would have to update every application and recompile it, and it becomes a Herculean task. So there is obviously a need to have a library that does the thing. Otherwise, you would end up in a situation when different applications implement this slightly differently, and this is no good at all. And you can't easily ensure that they are following a system-wide policy if it exists, because, like, for the same reason, they're doing this its own way. So that's why Linux-PAM, well, it was not called Linux-PAM those days, but anyway, it's actually a framework that allows to do this in a way to avoid these issues I mentioned. The way it organizes things is it splits, well, it organizes by splitting the whole thing into 4 distinct management groups. It's authentication that answers the question whether the user is actually the one it pretends to be, and grants credentials when necessary. Second management group is account management. It answers the question whether this user is allowed to use this service at this moment. And session management that actually prepares the session for the user and then cleans things up. And sometimes there is also password management that prompts for a new password, whether it's because the old one expired or maybe because it's actually the tool that's designed for changing passwords. It enforces password quality rules and actually changes the password. So because this is so important, I'll talk about this in a bit more details. So authentication, which answers the question, are you who you say you are? There is a classic modules for this that check password according to the shadow entry. The classic one is PAM Unix, but others are available, and I know that some distributions use different modules. Well, for validating a dongle, you could use our specific modules for this, and also for biometric scans. There is a module to access an SSS daemon, and there are a few modules, I think, for one-time password thing. For account management, the basic PAM Unix module checks whether the account is enabled and checks expiration. There are modules to do additional things like time-based restrictions or restrictions based on failed login attempts and on other things like whether this user is allowed to access this service and what's not. A lot of modules are doing session management. For example, there is a module for kernel session querying management for setting up traditional limits for various other things like to register user session in the systemd login manager, to create home directory not for local users usually, because for local they already exist. And when you're about to change your password, there are several modules that do various kinds of password quality, and actually the one that changes the password. So a lot of these things. As a result, we have a clear separation between applications that just request some generic things like this for management, implementing of these for management policies, and the PAM framework that does the thing. Just a few words about the application part because it will be important later. Various management groups have different number of API functions to do the thing. For example, authentication management group has two of them. One is authentication, and another one is setting credentials, or changing or deleting or whatever. The account management and password management has only one function, and session management also has two, like opening session, closing the session. This will have some very important implications later during this talk, so you will see this slide maybe once more later. So how this very flexible thing called PAM is configured? There are a lot of configuration files. Every service, as I said before, has its service-specific configuration file. They are currently stored in etc pamd directory. They used to be slightly different, like 20 years ago there was other options, but I wouldn't mention them because nobody is using all the ways of configuring PAM nowadays. So just think of this as a single file for a service. They are literally named after the service names. Like you will find in this directory files like login or su or shd and so on. So when the service needs to authenticate user, it calls the PAM authenticate function, and this way it tells the library that first it opens, it calls PAM start function and says that I am for example, login service. And then it calls PAM authenticator and says, please handle authentication according to the configuration in my service file. So yeah, if this file doesn't exist, or if this file doesn't describe this particular management group, then PAM falls back to its default configuration, which usually denies access. So maybe it would be good to mention here that PAM modules could implement different management groups, but most of them don't implement PAM management groups, all of them. Some of them implement only, for example, authentication or only session management. But some of them implement all of them. So besides service-specific configuration files for PAM, there are common files. They were introduced like about 20 years ago, I don't remember when, or maybe a bit earlier. And the reason they were introduced is that to avoid the redundancy, because like many service-specific configuration files used to do relatively the same thing or had a lot in common. So these common parts were moved to common configuration files, and they are included this or that way. And it actually helps to implement system-wide policies. So the configuration files is the way to define how these modules are being loaded and how they are being used. These modules they are the main workhorses well, they are actually pluggable authentication modules. So the whole thing is called after them. These are shared objects. They are loaded dynamically according to the service configuration. They are traditionally located in lib security or, well, on 64-bit systems in lib 64 security. Oh, well, it's distribution specific. Yeah. Some modules are very generic, but most of them are designed to perform very specific tasks. Linux-PAM project contains a bunch of, well, relatively standard modules, but there are a lot of third-party modules provided by all kinds of projects. I would just like to highlight these very important two modules called PAM deny and PAM permit. PAM deny, as you could guess, denies access, and PAM permit permits. Well, it's so important that, right, even though the simpler the module is, the more important it is. So let's talk about configuration file syntax, because it's the most mysterious part of the Linux-PAM. So I'll be talking mostly about this today. As you could guess, the configuration file consists of lines. And every line has very specific syntax. It has 3 mandatory fields and 1 optional. The first one is a type, which is the name of the management group. The second one is a control that says how to interpret the return value of the module. The third one is the module name, or it could be module path, but nowadays, well, it's discouraged to use the full path to the module because they are by default in the well-defined places. And some modules actually have arguments. So this is in this talk, I will be using real-life examples, sometimes simplified. And this is well, actual extract and simplification of a service file for login service from Fedora. Well, as you can see, there are quite a few lines, and for some management groups, there are more than one line, and for some, just a single one. By the way, if the management group name is prefixed with a dash, it means that its error output is silenced. Sometimes it's useful when you're using this in conjunction with optional control. So now let's talk about these controls. These are like main things of the configuration. So let's go through each of them. So the most used one is called required, and as you could imagine, this means that this particular PAM module should succeed to the whole management group, the whole stack to succeed. By the way, this sequence of modules within a single management group is called stack, but it's not a stack. They are processed sequentially and not as last in, first out. The reason why it's called stack is a bit mysterious. Maybe it's because it's a pile of things. Nobody knows exactly. It's a very old term. But it's used widely, just not to be confused. It's not a stack. But we will be using this word stack because it's all over the documentation. So a lot of these modules, as you can see, some modules are required and some have other controls. If module is returning failure and the control is required, the processing of the stack is continued, but the error is remembered and the whole result of the management group would be a failure. Unlike required, requisite terminates the processing of the stack in case of a failure. Otherwise, it's treated as required. And the reason to do this is that sometimes there is no sense to proceed with the stack. For example, if the password entered doesn't pass the quality check, then it's no use to do changing or it's not, because it has no sense. From the other side, why it would make sense, despite of the failure, to proceed the stack, it's mostly to avoid side channel attacks by measuring timings. Otherwise, it would be easy, for example, to guess usernames in the system by timing how long the PAM stack is working depending on the username, and that kind of leaks. So another control value is sufficient, and what it does is that it's kind of more optional than required. So if this module succeeds and no prior required module has failed, so the result of this line is success, and the stack processing terminates at this point. Otherwise, if there are failures before, it's not terminated and proceeded because of the previous failure. For example, you can see this excerpt from the SU configuration. There is a module called root_ok that grants access for the root, and the idea is that SU shouldn't ask for authentication tokens for passwords for root, because root is kind of allowed to switch user. So that's why if root_ok grants access, then SU doesn't run PAM Unix authentication. And there is an optional keyword that says that the failure of this module is not essential unless it's the only one. So they usually can find these modules in the session stack for executing some setup for modules that could fail or could even not be present in the system. When these modules are not present in the system, usually you use also dash in the prefix of the management group. So that wouldn't be any error messages because the module is absent. So these were 4 main control values that existed from the very beginning, but later some others were introduced. There is an include directive that allows to include other that's called common configuration files. And well, actually, I contributed to this feature about 20 years ago. So here you can see a real SU configuration file from Fedora. And you can see that it's used a lot of this. Include directives to use system auth and post-login configuration. And there is a similar thing that's called substack. that unlike include, it creates its own substack, and the failure of the substack affects only it, and the result of this substack treated as like a regular module. So if, for example, there is a sufficient keyword in the common file being substacked, so the whole thing is, the substack is finished with processing, but the main stack just receives like success as if it was a module. Okay, this is getting more and more mysterious. There is an advanced syntax that some people are not aware of, and it allows to do more complicated things. Like the syntax is that for each return code from the model you care of, you can specify an action. Well, the return codes could be specified as those that the PAM library supports, and there is also one specific keyword called default, which means all return values not mentioned. So, and actions are essentially similar to the main control values. Like there is ignore, there is to ignore the return value, bet to fail the module, die to fail the module and stop processing, OK to succeed and continue processing, and done to succeed and stop processing. There's also reset, which is not really used nowadays, and very important thing that you can specify an integer number, and this means to jump over the next n lines in this stack. That is, the next lines in this management group. So you can describe basic control values in this syntax. So to understand what it means, required is essentially this way. You can describe it this way. Is like OK in case of success, or when the new authentication token is required, and when the return value is ignored, then ignore, and all errors, all the rest is treated as bad. This way you can define all these basic things. So this allows to implement more complicated logic and even do conditional branching. But it's still not a Turing-complete language, so it's not that bad. Here's an excerpt from system.alf file from Fedora. You can see, for example, how this extended syntax is used to implement the branching, like for the local user, using the local user module. For example, like the idea is that PAM PV history module is designed only for local users, and for remote users, it has literally no sense because the policy is implemented elsewhere. So in this case, the next line is skipped when the user is not local. In this case, PAM local user returns an error. By the way, someone, it's a real life, except from the real life configuration file. And here you can see this funny thing, ignore equals ignore, which means like ignore the return value in case local user returns PAM ignore. But local user never returns PAM ignore. So why this thing is here, nobody knows. I'm just using real life examples, and they sometimes contain real life bugs. But that kind of bugs are harmless because it doesn't affect anything. It just raises questions. You start thinking, would this model return this error? No, it couldn't. And another example is very similar. So there is a model that tests some things, and for example, in this case, if service is crond, then it does, for some reason, skips PAM Unix session management. Well, I don't know why, but well, it's what this line says. Okay, the most mysterious thing. It's a real case from a real Linux-PAM issue. Somebody asked us why in this very simple example, PAM-env kind of always returns PAM-ignore. So the PAM configuration doesn't work. And to explain what's happening here, I want to bring back this table. So for PAM authentication, there are two entry functions. And there is a not very well-known feature of the PAM library is that when you are calling the first function, it defines and fixes the sequence of modules that are going to be called also when you are calling the second function. So in this example, when invoked by PAM authenticate, PAM-env module does nothing because that's how it works. And it returns PAM-ignore. And according to this rule, PAM framework decides that the next line should be skipped. But then, during PAM set-create stage, it's already decided that the line should be skipped. So it's against expectation of the person who asked this question, because he didn't know the frozen stack concept exists. Okay, I'll have a few minutes to touch on the troubleshooting things. And the common things that happen, and the most, I would say, dangerous thing people are aware of is not to be getting locked out. Well, especially if you're accessing the system remotely. There are also various other things that can go wrong, because like if you're like using modules not according to the documentation, or simply typos could disrupt the whole thing. Well, configuration files are important. So what could I say? Use your common sense. Know what you are doing, back up before making changes, always test your changes, do your changes increment. Well, it applies to anything, but in case of configuring the way you're accessing the system, it's kind of important because it can lock you out. Well, and note that many distributions have very, very useful defaults. So before starting to implement this from scratch, like really have a look at this. And there are also tools like AuthSelect that allow you to not dive into the configuration in many popular cases. So if you really have to troubleshoot things, first of all, look at the logs. Like PAM is very verbose by default and has a lot of information, and many models also has debug argument. And this argument makes them even more verbose. And the first thing I should have said, but I didn't, is that read the docs. PAM has a lot of documentation, really a lot. And it tells a lot of, almost all I've been talking today is written somewhere in these docs. Just read them. And if you really have to debug things, well, there are debuggers. It would be really strange if I didn't mention strays during this talk. So, yeah. A few words about using strays. Well, usually you attach to a daemon to the service that does the authentication. So you attach to this. Normally, you want to follow forks because it forks for handling each authentication. Most likely, you don't want to follow the actual service. So you detach on execvia, and when you're debugging timeout issues and that kind of thing, then some other options to track timing that strays has is also useful. Well, strays can do a lot of things, but other debuggers are available. So I think that's mostly all I wanted to talk about today. So, yeah. If we have any questions, we have about 5 minutes.
So, So let's say I'm implementing util-Linux login. My question is, how do I know what the PAM is going to ask for? Depending on the configuration, it could ask for a password, it could ask for a fingerprint, it could ask for a YubiKey. Is there any way to ask, like, what is PAM going to want me to
Well, it's all
with?
I don't think I need to repeat the question. So, okay. So all is defined in the configuration file. By looking into configuration file, you could easily predict what each module is going to do. Like if you use PAM Unix, it will likely ask for the password.
Yes, but I can do this by hand manually. But let's say I am a login manager and I want to show a pretty picture. Please press the YubiKey. Is there any machine-readable way to?
This would mean that whether you can dry run the password stack and find out what it will do. And I don't think you can do this. Well, it's not in the API yet.
So whenever I introduce a new line in this arcane syntax into a PAM stack, I'm kind of worried that I F something up. And I always end up testing my changes with SU as the service, because that's the one that I need the least. And I have sudo configured as another way in to the root prompt. Is there a better way than doing this? Is there some PAM exclusive testing vehicle one could use to test PAM stacks?
There is an arcane tool called PAM test, but it's not widely used. So I'm not aware of that kind of tool specifically designed and at the same time popular and maintained, because this PAM testing is not maintained. So yeah, you can do this, but other various services use different configurations. So when you are testing something for SU, you will test it for SU, and Login would do things somewhat differently. So it wouldn't be that applicable. But when you are changing the common file, it would affect several modules. So the answer to your question is probably there is no accepted way of doing this. So people do it their own way. But you're welcome to volunteer and contribute this thing. Everybody would be thankful, I think.
So this is maybe not super related to the talk, but PAM Unix currently still relies on a set UID or file capabilities-based helper to read etc shadow to be able to verify the password. Leonard actually opened an issue on the GitHub repository to replace that with something that isn't set UID or file capabilities-based. Would be great if you could take a look at that, because...
Well, Torsten already answered in that issue that he has proof of concept implementation for this.
Yeah, but he told in a private chat that he was also waiting for your input before.
Oh, I didn't know. He could explicitly write this in that issue.
But yeah, it would be great if you could comment with your thoughts and ideas on that.
Okay. Well, it makes sense. I didn't look into this specific implementation, but the generic idea makes perfect sense.
So the stack runs into process. Is there a plan to move it to a service-based approach where the authentication happens in a remote process?
Sorry, could you speak a bit louder? Otherwise,
I need to. Oh, okay. So this stack runs into process. Is there a plan to move it out of a process into a service and just communicate over some local IPC?
Do you mean in generic or per module basis? On per module basis, you can do anything.
No, in general.
Well, I don't know of any plans because this would, like, I don't think it would be backwards compatible. Well, I'm welcome to suggestions, but this would be a big thing. So I'm not really see anything going in this direction until somebody actually comes with a workable proposal. Thank you for coming.